Welcome. We're going to cover Chapter 12, Security and Network Design. We're going to describe some of the functions and features of network security and some of the devices that we use to secure the network. How we implement some security on switches and track the process of our authentication, authorization, and auditing, our AAA, on a network. And then we'll discuss some options on the network access control. And finally, configure various security measures on our wireless networks. So non-security devices that have some security features are proxy servers and access control lists, or ACLs, ACLs. And actually, it's not really a device, but they're used for security. Proxy servers, though, are a device. They're not really utilized or seen as a security device, but they can come with some security features. Specialized security devices such as our firewalls, our intrusion detection systems, and intrusion prevention systems. We'll definitely cover those. And then there are multiple options for our network security, right? Which we utilize what is called a layered security and defense, right? So you don't just use a firewall, you don't just use an intrusion prevention system. You have multiple devices or layers of defense. So our proxy server, if you know what a proxy is in the legal term, it's something, proxy can do something for someone else, and that's what a proxy server does here. It acts as an intermediary between external and internal networks. So say you have a user on a corporate, all your users in the corporation go through the proxy server, and then the proxy server makes the request to the web pages on behalf of the corporate users. And then thus you can screen all incoming and outgoing traffic on the web because they're going through this one centralized location, or the proxy server. And you can help use it to manage your application layer. It appears as it appears as an internal network server to the outside world, but it is a filtering device for the internal LAN, and users don't even know they're going through it most of the time. And one of the important functions is preventing the outside world from discovering the addresses of the internal network, and also really it's to buffer the internal users and their requests, and being able to filter them out and check them. Now, a reverse proxy provides services to internet clients from servers on its own network. Provides identity protection for the server rather than the client, and is useful when multiple web servers are accessed to the same public IP address. It's definitely a way of filtering, a reverse way from servers to users instead of users to servers. So it's reverse. So it's you doing the communication on behalf of another server instead of users. Here's an example of a proxy server, right? So it's sitting there in your network main area, of a corporation or organization. You have your users internally. You have the firewall that separates the internal, external. networks, and then you have the proxy server, probably living in a DMZ, but it doesn't have to, but it could be in your DMZ that's neither in or outside. So all right, so routers, right? Examine packets, forward packets, determines the best place to forward the packets. But they do have access control lists, or ACLs, or apples, and they're used by our routers to decline forwarding certain packets. So if it meets a certain criteria, it'll drop it. It acts like a filter, and you can filter and deny traffic on one or more of these parameters, right? Is it using IP or ICMP? Is it TCP or UDP? What was the source address? What's the destination address? What port number is it using, right? So it can be any and all of these things, right? So for example, you could say, if the source IP is 10.10.10.1 and it's an IP packet, drop it, or if it's the destination is 10.10.10.1 and it's destined for port 3389, drop it, right? There's a combinations of things that you can do. So, right, a router's job is to receive packets, to examine the packets, and then make a decision either to drop or forward the packet, right? But it refers to the ACL list for permit and deny criterias. It drops it if any denies are matched. It forwards the packet if it's permitted, right? Then also, if it doesn't match any criteria, it's dropped. It's just called the implicit deny rule. So, on most routers, each interface must be assigned a separate ACL, and different ACLs may be associated with inbound or outbound traffic. So here's an example of the incoming packet. It checks the first ACL, or rule, and then if it matches a permit or a deny, it goes. If it matches a permit, it goes out. If it matches a deny, it goes and gets dropped. If it doesn't do either, then it goes to the next rule, and then the next rule, and then finally, if it doesn't match any rules, it's dropped. All right, the access list command is used to assign a statement to an already installed ACL. Must identify the ACL, include a permit or deny argument. So example, below, to permit ICMP traffic, right, would be the access list, ACL _2, that's the ACL, the name of the ACL. Permit ICMP to any destination, right? So another example is access list ACL to permit TCP, host 2222 and host 5555. So only permit traffic from host with the IP of 2.2.2.2 to the machine 5.5.5.5, right? But ACLs, the more you have, the slower performance you have on the router, because the more they have to test and scan, the more time takes for the router to act. Now, firewall is a specialized device that typically involves hardware and a software combination. usually placed between two interconnected private networks, or between private and public. That's a network-based firewall, which is what you typically think of when you think of firewall. And may also see firewall features integrated in routers, switches, and other network devices. Think of our home routers. They have a built-in firewall as well. Other types of firewalls only protect the computer in which they are installed, also known as a host-based firewall. Here's just a typical network setting. Shows the firewall in front of the router, and then you got your router, your switches, and your internal network, private network. These are just examples of some firewall devices. Now, the first round of firewalls were packet filtering firewalls that are simple firewall. They just examine the header of every entering packet and can block traffic entering or exiting. A LAN, by default, blocks most common security threats. It's pre-configured to accept and deny certain traffic types. And then you can customize the settings. Here is a firewall here. You got your inbound and outbound traffic on the external interface, and you got your inbound outbound traffic on your internal interface. And so common packet filtering is just like ACL's list a lot in the ways. Source destination IP addresses, source and destination ports, but it also has flags that you can filter on. Transmissions using UDP or ICMP. Packet status is the first packet in the data stream. Subsequent packets, is it inbound or outbound? So the status. You can do port blocking, permits connections to and transmissions completing through certain ports. So then you have some additional firewall functions that are not necessarily in every firewall, but you can have, it could encrypt the traffic, you do user authentication, centralized management, easy rule establishment, content filtering based on data contained in the packets, logging, auditing, protect the internal LAN's address identity, monitor packets according to existing traffic streams, right? Now then, a stateless firewall manages our packets as a standalone entity without regard to the active connections. So it's stateless. It doesn't understand about state, but we have stateful firewalls that can manage connections and know that you're already established connection and treat it differently or deal with it differently because it's aware of the state and it's already aware that you're authenticated or that you've already been communicating. UTM, or the Unified Threat Management, it just combines multiple layers and multiple devices into a security appliance and into a single safety net, right? But it does require a great deal of processing power because you're combining what normally were separate devices into multiple devices. Then we have our next generation firewalls, right? So they have built-in application control features. They can do just about anything, including trying to mask social security numbers, things like that from web pages. It works at the application level. So, for example, say your developers are creating a web page and it asks for social security numbers in there, but they forgot to hide the social security numbers from view. Your firewall, this application firewall, can actually go find those and mask them, and so they don't actually show the whole number, because they inspect the application level. And I mean, it takes a lot of administrative work, but that's the fine granularity that you can do. I mean, you can do just about anything. You can actually change web pages based on certain criteria. Say certain data should never be shown on the web. And it could actually look through web pages that are being submitted by your web servers and your developers, and hide and remove certain information or change certain information. I mean, these application firewalls are incredible in what features and options they have, but it's a lot of overhead, it's a lot of administration. But there's almost no limit to what you can do with them. Let's see. All right. Right. So the most common cause of failure for a firewall is misconfiguration by an administrator. So you definitely don't want to restrict your network so far down that users can't do what they need to do, and then you don't want too many rules and punching too many holes into the firewall, because then it's almost making it worthless, right? It doesn't do anything if it allows everything, right? You need some security, but you don't want so much security that you disable or prevent business from functioning. It's a fine line. All right, IDS, intrusion detection systems, right? They can be a standalone device or built-in software into some other devices, but it's going to monitor our traffic and generate alerts. Anything that it feels is suspicious based on its criteria, but it's only going to generate alert. And there's two main types, right? Statistical anomaly compares our network traffic to predetermined baselines to determine what's suspicious, or signature based, looking for identifiable patterns of code that are known, right? Known exploits, known vulnerabilities, but it just detects it. It can't do anything other than sound an alarm or email you or something of that nature. It just detects. Whereas intrusion prevention, we're still on the IDS. All right, so if it's on a host, it's host-based. If it's network-based, it's a network-based device. So on the host, it's just running on that computer and only protecting that computer. Whereas if it's a network-based, it's securing and monitoring all the traffic for the network. But typically it needs to be at the edge or in the DMZ, somewhere where all the traffic's coming through. And when you're doing that, typically you're using a port mirror, right? So it makes a copy of the traffic, and then sends it to the device for processing. But it can have a large number of false positives can be logged, and you can be responding to all kinds of alerts that are nothing. But it does log it and let you know. Intrusion prevention systems, or IPFs, so they also detect and look at and find suspicious activity, but it also prevents the traffic from flowing on the network, and can be based on the originating IP. Protect, once again, you can have network-based or host-based. And here's an example. You've got in between the firewalls and the DMZ, so you've got your external and your internal firewall, and you've got your network intrusion prevention system setting in between, and all the traffic goes through there. But a prevention system, it can actually stop the traffic if it finds it to be suspicious. Then you can have one on the internal segments as well, again, or you can have it running on a host or even both, right? So this server here is running a host intrusion prevention system, in addition to having a network intrusion prevention system. All right, security information and event management, or SIEM. They're basically configured to capture and evaluate all your log data, right? Looking for significant events that may require attention. And then, of course, the effectiveness of any SIEM product is by the amount of storage and the data that you're generating. And then you can hopefully fine-tune the configurations, and, so tell it what events should trigger responses, what are you looking for, what are you concerned about. But then someone should review the raw data on a regular basis to ensure no indicators are being missed by the rules. Nothing important has gotten missed. All right, so now we're going on to our switch management. How paths between switch are managed, switch security concerns. So we've got physical, data link, and our network layers. All right, so we can make our networks fault tolerant, right? So you can have redundant switches, right? So you've got A, B, C, and D switches here. And if any one of these fails, there's still a path to switch F from E, right? So that's redundant, but it also creates traffic loops, right? So if there was a broadcast from one of these machines on switch E, it would just kill the network, because it would just keep going an endless loop and just keep generating traffic off of all these switches, and would bring down the entire network. So what we've done is enabled the spanning tree protocol. So STP, spanning tree protocol, prevents our loops. So it calculates the paths to avoid provincial loops, and it blocks links that would make a loop. But then if a switch goes down or is removed, spanning tree is recalculated, and then the next best loop-free data path is used. So here in this example, right, the path from switch E to A is blocked, and the path from D to B is blocked, and B to F is blocked. But we can still get through, right? So B can still get all the way through to F. It has to go B, A, C, D, right? But all these loops are now blocked, right? So there are no more possible loops. But if you were to lose a switch, say you lost switch C, right? It would recalculate, and then it would unblock from switch A, and then probably unblock from switch B and D and B and F, right? Well, maybe, yeah, and then block D to F. But it would reroute the traffic. So spanning tree information is transmitted between the switches using the bridge protocol data units, PDUs. So you must take precaution, because BDUs, BDU guard and PDU blocks, these bridge protocol data units on any port serving network hosts, right? Right, so that these can't be considered as paths. So you need to block any port that has a computer or device plugged in that's not a switch, right? Only switches care about spanning tree protocol. So you have to block those ports. So you can filter it, block out specific ports, and then root guard prevents switches beyond the configured port from becoming the root bridge, right? Because there's one switch that's going to be considered the root, and you want to prevent certain ports from becoming root. So there's a newer, faster version of spanning tree protocol. It's called Rapid Spanning Tree Protocol, and then there's Multiple Spanning Tree Protocol. Trill is a transparent interconnection of lots of links, which is a multi-path link state protocol. Shortest path bridge is a descendant of spanning tree protocol that operates at layer 3, right? And keeps all potential paths active while managing flow data. So then certain manufacturers have designed their own proprietary versions of spanning tree, which includes Cisco and Extreme Networks. So any unused physical or virtual ports on switches should be shut down, right? So you'd use the shutdown command on Cisco and other routers and switches. To enable them again, you use the no shutdown, double negative, right? But that's how you enable a port on Cisco switches. Another Cisco command that we can use to secure switch access ports, ports that are used by PCs, servers, is the switch port -security, or just port-security on the highway switches. And it's essentially a MAC filtering function that protects against MAC flooding and other, bogus MAC addresses. The same thing is on a Juniper switch is the MAC limit. Restricts the number of MAC addresses allowed in the MAC address table, and it configured with the allowed-MAC command. So users on a network, right, need to authenticate, have authorization, and accounting. It's AAA, right? So authentication is verifying who they are. Authorization is once you know who they are, what can they do or cannot do, right, on the network. And then you need to keep an account, a log of the systems or network usage. Certain times you may want to understand how long someone's been on some system, or when they log in. So that's the accounting piece. Right, so a user can be authenticated to a local device or to the network, right? Local authentications are usually usernames and passwords that are stored locally, which has some advantages, but a lot of disadvantages too. It's low security. It may be hard to maintain, but it could be some, I don't know about the reliable backup access, but it's stored locally. It's very low security. If the device is stolen, they have unlimited attempts to crack it. And then every computer on the network is responsible for its own resources, so it's hard to manage. Right, so in Windows you can switch from local to network, which would be domain, so level security, and you use that system's property dialog box to do that. Here's an example of that. You would just click on the network ID, and then select this computer as part of a business network, and click next. And then you could be asked to join a domain, what domain you want to join. So right now this is a local work group, but you'd rather have the network authentication that like of Active Directory and the domain gives you. It'll harden your network by requiring secure passwords. You have easy access to control and manage users and access. You can have additional restrictions, time of day, total time logged in, where they're logging in from. Lock it if they've had so many bad login attempts. Don't allow them to log in if they're not in a certain location. Right, so then user access to network resources fall into two categories. Privilege or right to execute, install, and uninstall, or permissions to read, modify, create, or delete files. We can have role-based access control. It is a popular authorization method. Your administrator assigns privileges and permissions that are necessary for users to perform their roles, whatever role they are. So they create groups associated with these roles, give them permissions and privileges, and then put users in these groups. Each user can only be a member of a single group. With role-based access control, yes. It's not necessarily true for all situations, but if you're using role-based access control, one user can be a member of a single group, but that's not how it usually is done in most places. All right. So you have accounting, right, is the event viewer. Is one aspect, but you have logs generated by all kinds of devices. Network access control is a solution that employs a set of rules called network policies, and they help determine the level and types of access granted to a device when it joins the network. So NAC, or network access controls, authenticates and authorize a device, right? So like when you're joining a Wi-Fi network, you might be communicating with a network access control device, and it will scan your computer, and if you don't have an up-to-date virus scanner software, it may not allow you full access to the network until you've updated your virus signatures or something like that. But that's a network access control device that's doing that. It's authenticating and authorizing your device on the network. An agent may need to be installed on the device before it can be authenticated. Right, and there's two types of agents. Non-persistent remains on the device long enough to verify compliance and complete authentication, then uninstalls. Or a permanent or persistent agent, it's permanently installed on the device. Devices that don't meet compliance, they, like I said, could be placed in a quarantine network until its issue is resolved. They have very limited network. Right, so several types of authentication service protocols exist, right? One of the big one is LDAP, right? So Microsoft uses LDAP. It's Active Directory. It's an open LDAP. Well, it's not an open LDAP. It's an LDAP. It's directory services, and it stores all the account information, usernames, passwords, other information. These directory services include, Active Directory, Open LDAP, 389 directory servers. A lot of them are based off the LDAP lightweight directory access protocol. Right, as above, all three are built to be LDAP compliant. And then Active Directory, or AD, utilizes Kerberos for its login authentication process. It'll use the database, the LDAP database information to authenticate a user. Kerberos is cross-platform. It works on Unix, Windows, Mac. It uses key encryptions to verify the client's identity, securely exchanges information after the client logs on, and it has significant security advantages over most of the network operating systems' built-in authentication. Terms to know with Kerberos is principal, right? The key distribution center and the ticket. Right, so Kerberos uses tickets. Runs two services. The authentication service, that's used to initially validate a client. Say, yep, you are authenticated, you're valid. Then it has a ticket granting service that runs separately from the authentication service, and also runs on the key distribution center. And this alleviates the need for the client to request a new ticket from the ticket granting service each time it wants to use a different service on the network. So basically, when you log in, you get your ticket, and it grants you permissions on the network. Here's an example, right? So you're logging in, and it says, you go out, it says ticket please, it goes to the AS, it says, yep, you're verified, here's your ticket granting ticket. Then you go out to the ticket granting service, and you ask for your ticket. It provides you a ticket for service A. When you go access service A, you submit your ticket, and then the server looks at it, says, yep, you're valid, you're granted access, and so here's your session. Right, so the authentication request, username, timestamp, and the user's password. It's very time sensitive. If the time is off on your computer and the Kerberos server, that will cause issues. So you need to have your time in sync, and then your response, right? So you'll get your username, your session key, and your ticket granting ticket. And let's see here. And ticket response. Right, and so then when you're requesting the service, you send your username, timestamp, and the service ticket with your with your session key. Single sign-on, SSO, right? It's a form of authentication that when you sign on one time, it allows you access to multiple systems or resources. And primary advantage is you don't have to remember passwords or have to log in every time for each service. Disadvantage is that once authentication is cleared, the user has access to numerous resources if they should or not, right? They have access to everything without having to re-authenticate. So if they leave their workstation open, somebody has full access, and they, even to secured areas maybe, and they don't have to re-authenticate. So that could be a disadvantage. When you're logging in, you could have two-factor authentication where you have to provide something and have something, right? And then multi-factor authentication requires two or more pieces of information, such as your password and a fingerprint, right? And then we've got different categories of authentication factors, right? Something you know, password or PIN, something you have, right? A smart card or something like that. Something you are, your fingerprint, iris scan, facial pattern, somewhere where you are, your location in the building, a certain network, something you do, specific way you type or speak, right? Because we all seem to, probably have different type speeds, things like that. And then multi-factor authentication requires at least one authentication method from at least two different categories, right, to be multi-factor. Security token is a device or application that stores or generates information. Radius, right, remote authentication dial-in user service. It was created in dial-up era, but it is still useful today. It's open source and standardized. Runs at the application layer. Can use either UDP or TCP. Can operate as an application on a remote access server or as a dedicated Radius server. They're highly scalable and are typically nowadays are used to authenticate wireless, mobile, and remote users. And Radius services are often combined with other network services on a single machine, right? Because there's very low overhead. It's pretty fast, but it provides authentication, authorization, and accounting or AAA services, specifically for like wireless connectivity. And here's an example, right? 3 different users, a VPN user, a wireless user, and just a normal workstation user. They all connect to the Radius server to do the authentication. It checks the user accounts database and grants them access or not. The Terminal Access Controller Access Control System Plus is a newer form of like a Radius server. It offers options of separating the authentication, authorization, and auditing capabilities, whereas Radius, it's all together. It does all 3. This can separate it out. It relies on TCP, not UDP. It's proprietary protocol developed by Cisco, typically installed on a router or switch rather than a server, and it encrypts all information transmitted for AAA. Right, and so we know that we shouldn't use WEP. It's not secure, right? WPA, right? And TKPI was a quick fix, but now we've got WPA2, and so it's more improved. They're working on others, but right now this is fairly secure. It's using AES, Advanced Encryption Standard, just faster and more secure than TKIP. We have two versions: personal version, which most of us have used, and then enterprise version, where there's an actually authentication server, typically a Radius server, that does the authorization, and makes it a little bit more secure, and logs the information. Right, so you got supplicant, the authenticator, so the wireless access point would be the authenticator, the supplicant is the device wanting on, right? And then you have the authentication server that performs the actual authentication. And this is just showing the process of the request going through. You can use TLS to encrypt everything going between them, right? We'll use PKI certificates to exchange the keys and authenticate both the supplicant and the server. You could do protected EAP, which is tunnel based, where you send everything through a secure tunnel. And then you have EAP fast, which is a flexible authentication via secure tunneling. It's a form of tunneled EAP developed by Cisco and works similar to PEP, but only faster. And that is our chapter 10.